Now that we've completed section 8.1, 8.2, 8.3, we are going to practice some word problems that will apply to our quadratic functions, but have some more applicable real-life meaning. We're going to do 2 examples, and then your classwork that you'll submit for credit is attached in a different document, and it has 2 other word problems that are very similar. So let's look at this first one. For this first word problem, it says the trajectory of the water from fountain A, so down here is fountain A, I'll use the red for that, is represented by a function in standard form. So I'll use red, and this all represents, this fountain right here. That's the equation that models fountain A. And this is standard form. While for fountain B, now we'll use a different color. For fountain B, let's do blue for B. Fountain B is represented by our table of values. So over here, if we look at the second fountain, fountain B, that's represented by the table of values. Compare the vertex of each function. Which trajectory reaches a greater height? So first of all, what we want to think about is when we have a picture of any parabola, right? If we're looking at something like a fountain, right? No matter what form it's in, ax squared plus bx plus c, or, a times quantity x minus h squared plus k, we're able to now calculate this center point, right? The vertex. And when you find the vertex has coordinates, right? An x coordinate and a y coordinate. So the y, if you look at the y-axis, right? Your y coordinate represents, we say, your max or your min, right? Or the height of something. So something is its highest or lowest, right? Depending on the image. So it's either the highest or the lowest wherever you see the vertex is. Y, the y coordinate specifically represents the height. Okay, so let's write height. Up and down, right? Or the max or min value. Yeah. Yx, since the x-axis runs in the opposite direction, this is would be our x-axis, right? X-axis would represent, for example, distance of something, right? So the x coordinate of your vertex represents when you will hit the center, how far out you will be when you hit the center where you'll reach that height. So for example, if I was asking about a mouse or something jumping, and at what point, how far out were they, or how long, if the x-axis was time, right, and the y-axis was height, a question could be like how much time has passed when the mouse was at its maximum height. And so you would say the x coordinate, because at x time, that's when it reaches its y value or its max or min height. So that just talks specifically about the vertex, okay, and kind of what each component coordinate represents. So we're looking at both fountains, right? And if we look at fountain A, here it is. And we're trying to look and find its vertex, because when we find its vertex, we then want to zone in on the y coordinate on the vertex, because that y coordinate of the vertex is going to talk about the height, how high this fountain is. So let's do that. And then we're going to compare to the y coordinate of the other picture and see which one is higher. So let's work on image A. Let's focus and try to find the vertex. Let me see if I can do something. Okay, let's see if I can write on here. No. So if we look over here, we have, I'm going to do text. Insert, Let's see if we can insert some text. Insert text box. So give me a second. It's slow to do stuff on the computer. So when we look at equation A, we know that A equals -1, B equals 2, and C equals 8. If we're trying to zone in and find the vertex, right, we know that the x coordinate is -b/2a, and we're going to need that, and we're going to plug that value in to find y, right, the y coordinate. So if I'm trying to find the x coordinate, we'll do x equals -b/2a, which means it's negative, well, we're going to put 2 in for b over 2 times the quantity, a is -1. And this is going to equal 1. And this equals 1, right? -2 over -2. So now we know we have 1 comma question mark. So we need to plug 1 into our equation. So we have f of x, or y, equals negative. We're going to insert 1. We're going to square it. Plus 2 times 1 plus 8. We're going to simplify. So we have 1 squared is 1. We multiply by front negative is -1. Plus 2 plus 8. So we end up getting 1 plus 8, which equals 9. Therefore, our vertex let's write B. Our vertex is 1 comma 9. Now, when we look at this, it gives us some good information. It tells us that the fountain A reaches a height of 9 feet, right? So when we look at this, again, the vertex is super important. Since the vertex, since the vertex was 1 comma 9 for fountain A, we know that the height, right, I'll write H, I don't know why it turned different color. The height of fountain A is 9. 9 what? It's 9 feet, okay? So we know that for fountain A, it's 9 feet. We're comparing to fountain B. Now, if we look at fountain B, and we look at the table, we know that fountain B reaches a height of 10 feet. Okay? If we look at this picture, if we draw a picture, oh, sorry, this is very hard to write nice and neat, guys. Okay, so if this is -410, and we start to see, so I'm just going to point. If this is -410, and then over here we have -5,8, -3,8 right here, and then -2,5, -6,5. You see that we have symmetric points going down and down. Therefore, the ordered pair -410 shows where you're going to have the highest height. So the y coordinate of 10 is the highest point for fountain B. So we're really looking at 10, and we're comparing it to, we're looking at 10 and comparing it to 9, right? So 10 is the highest here. for fountain B. So fountain B, the highest is 10, and for fountain A, the highest is 9. Therefore, to answer our question, which trajectory reaches a greater height, it's fountain B. Fountain B is the one that reaches a greater height. It reaches a height of 10 feet. Okay. Watch the second video. Hopefully it doesn't do this, and I'll show you the other problem.